All right, we're recording and I'm going to go ahead and start the webinar. Okay, you guys should see attendees coming in here shortly and you're live. Good luck.
All right, welcome everyone to this session on the past, the present, and the future of the experimental methods in economics. We are very grateful to the Economic Science Association for making this session possible. We have a very tight program with 5 talks coming up, so I won't waste much time talking, and will give the floor directly over to our first presenter, Andre.
Thank you very much for having me. I hope everyone can hear me. It's a bit late here in Europe, and I'd like to talk today about a brief history of experimental economics, or the experimental turn. When a session is called past, present, and the future, it sort of implies that there might be some anxiety about the future of experimental economics, and perhaps looking at the past might help to alleviate some of the concerns. And so within the short period of time of the 15 minutes, I will try to make 4 historical claims. And unfortunately, I won't be able to substantiate them in much detail, but I'd like just to make these 4 claims sort of a take-home message about the early history, or the emergence of experimental economics in economics. So there were several transformations of economics in the 20th century that should be considered in relation to experimental economics. That's my first claim. And experimental economics is one of the transformations of economics that redefine the relationship between economic theory and empirical evidence. The second claim that I will make is that there has been a very long tradition of defining economics as a non-experimental science. And the third claim I will try to make is that the experimental turn, or experimental economics in economics, was about reestablishing the parity between theory and empirical evidence, because by the 1970s, the relationship was imbalanced, and was how it was perceived by the early pioneers of experimental economics. And the fourth claim is that besides experimental economics, there is a broader tradition of experimentation economics. And experimental economics is sort of the first attempt that succeeded in turning economics into an experimental discipline. So towards the first claim that I'd like to make is that 20th century in economics witnessed a tremendous change in the economics discipline. When you put 2 economists next to each other and they are a century apart, they would not understand the way how economics is done today and a century ago. And it was because by the adoption of mathematical modeling and formalism and econometrics, and to some extent also experimentation, economics was changed in a way that became more rigorous, or at least it was attempted to make economics more rigorous and scientific. And that, in effect, changed the notion of what is economic theory, what is economic data and economics, and what is their relationship. So a century ago, was sort of a standard beginning for any economics teaching would be The Wealth of Nations by Adam Smith, a literary text that would be explained and delved into. By mid-century, mathematical economics would start appearing, and also mathematical modeling and formalism, along with econometrics. And in the last third of the 20th century, when you have, say, Burton Smith and other pioneers, there is also experimentation in economics, that all 3 sort of change the way how economics is done and what is considered to be good economics. So for instance, mathematical modeling and formalism try to impart superior level of rigor through a compact, straightforward, practical mathematical rendering of economic propositions, which allowed an easier way of proving theorems and drawing otherwise unattainable consequences when you engage in sort of a literary textual analysis of economic arguments. Econometrics is a very interesting case, because what it tried to do, was to combine economic theory, statistics, and mathematics in a way that would increase rigorous thinking in economics. At least that was the claim at the foundation of the Econometric Society in 1933. And the reason why econometrics was developed was because economists who were at the forefront of econometrics believed that economics cannot do experimental research. There is no experimental method available to economists and no way of sort of controlling things in economics. And the data that is being available, there was an ability to isolate, to control, and to manipulate economic conditions. And whenever you run some sort of regressions, like what you see, for instance, the first econometric model by Jan Tinbergen from the 1930s without an error term, which was later developed in the 1940s, was that actually econometrics is a way of controlling for data and its properties. What happened in the post-war period was that this ideal of econometrics that would sort of marry mathematical reasoning and statistical economics sort of went into two separate ways. Mathematical economists, say Arrow, De Breu, and many others in the 1950s provided many interesting theoretical propositions and were able to prove them, but they were sort of disconnected with any empirical work, and sort of this solution between or division of labor between mathematical economics and econometricians became sort of frowned upon in the 1960s and 70s as these two activities became increasingly disconnected. And there were some reasons between economists that they were sort of unhappy about empirical work and also unhappy about theoretical work that had sort of little connection to any empirical agenda. So to my second claim that I would like to make is that there has been a very long tradition of economists claiming that economics is a non-experimental discipline. You have many statements in the 19th century by various famous and less famous economists. For instance, I chose a claim by the father of John Maynard Keynes, who claimed in 1891, very influential book, Scope and Method of Political Economy, that experiment is a resource from which the economist is debarred. Similar claims were perpetuated by Milton Friedman in his Methodology of Positive Economics in 1953, and even the very famous textbook by Paul Samuelson and his co-author William Nordhaus. Even in the edition from 1985, they still were claiming that economists cannot perform controlled experiments like chemists or biologists can do. And there was already a time when many pioneers of experimental economics were doing experiments for 1 or 2 decades. So where does experimental economics come into these two sort of historical claims, that there is a sort of attempt to reconfigure economics along the line of what is theory and what is evidence, and the tradition of claiming that economics is a non-experimental discipline? Well, experimental economics revisited the belief that economics is a non-experimental discipline. It grew from a handful of people in the 1960s and 1970s into a larger community in the 1970s, which continuously studied economic phenomena and theories through the application of the experimental method. It was not just a field, like a group of people, but it was also a distinct research method that tried to get hold within the economics profession. But it was just a bit more than just introducing the practice of economic experiments or borrowing them from the field of psychology or some other sciences. It was about all, and that's what the early pioneers of experimental economics would claim, about redefining the relationship between economic theory and the data, as it was sort of in imbalance in the 1960s and 1970s. So what it entailed to sort of redefine or sort of put economic data on par with economic theory was to build an infrastructure of research. And here are the sort of very broad claims that I make without being able to substantiate them in much detail. It's sort of some claims that are that have been subject of my own research for many years. And essentially what happened is, and perhaps this is sort of best way how to engage with the multiple processes that were going on together, was that from these early pioneers from the 60s and 70s, whether in Germany or in North America, at various places like in Arizona or at Caltech or at Pittsburgh or Texas A&M, this emerging group of community with a shared identity about sort of what they were doing experiments, were transitioning from an ad hoc activity to a continuous style of doing experiments, which required also an investment into a new location of doing research that was novel to economics. That is the economic laboratory. it changed from sort of ad hoc locations like classrooms where people would come and run experiments with pen and paper to a dedicated facilities, laboratories, which would be designed or purpose designed to run experiments already in the 1980s on computers. And this sort of continuous interaction of people and conducting experiments through trial and error and putting the experimental method to new applications into various new fields within economics, like law and economics, industrial organization, not just the typical market experiments of the 1970s or political or more group decision making and bargaining and things like. So this led to a stabilization of the experimental method. Perhaps the most famous example would be the 1982 paper by Vernon Smith, where he sort of lays down the five tenets of experimental economics, or properly controlled microeconomic experiments. And so while this sort of explains a bit sort of the community and the dedicated place, and also the stabilization of the experimental method, sort of explains part of the story, it does not explain how experimental economics became part of economics, or how economics became more of an experimental discipline. So, and that was through getting accepted by the larger economics profession, which did not have any direct experience with the experimental method. You have to see that most editors of leading journals were not experimentalists, or have, with one or two exceptions, never run an experiment. That there was a substantial opposition in the economics journals based on the referee reports available from the 70s and 1980s about the validity of collecting data in economic experiment. There are traditional complaints like you're using students, this is our artificial environments, people have little experience with the actual subject matter of the experiment, were raised, and that's something that the experimentalists had to overcome in the 70s and the 80s by sort of convincing the editors and the referees that the data collected in experimental conditions is reliable. And actually what they tried to achieve was that it's the experimental setting, which allows for a control environment and control collection of data, is the most suitable for studying abstract economic theory, because it gives the best shot for the theory. It's not field data that is sort of collected and needs to be you need to apply lots of additional assumptions about the quality of the data, but rather it's purpose developed data that is designed in a setting that allows you to control and provide detailed or controlled interventions in its creation. And once sort of there was a growing acceptance of the experimental method in the leading journals and other journals, this helped also to secure funding and also show the various applied possibilities of experimental research, like the FCC auctions in the early 90s and many else. And that sort of channeled further into growing of the experimental economics community and boundaries. I have not received any time limits so far, so I hope I'm on time. 3 more minutes. So, this was sort of the factors that sort of were feeding into each other and have led to a large acceptance of the experimental method in the discipline. So you see these various graphs of a growing number of articles in the leading journals, and also with after 2010 with more precipitous decline, but then a rebound. You see the growing number of the experimental economics laboratories now at around 250. Also the share of grants, NSF grants supporting experimental research has been growing from the 70s quite steadily. And many things happened in the 1980s that sort of together changed the way how economics can be perceived as an experimental discipline. So to my fourth claim is, so how about behavioral economics, or how about game theory experiments of the 1940s and 1950s? How do they fit into this story? And what I claim is there is a long tradition of experimentation in economics, not of just experimental economics, but experimentation broadly defined. say in the late 19th century, you had agricultural economics experiments studying how the crop yield is determined by various factors like the amount of fertilizers produced, or in the 1920s, you had managerial experiments about how lighting can influence the productivity of workers, time and motion studies of the 1930s. The first market experiments at Edward Chamberlain, whom I would claim is the first economist conducting economic experiments on an economic topic that would be accepted by economists as something part of economics. And so you have many episodes in the history of experimentation in economics. But what is defining about experimental economics, say by Vernon Smith and Reinhard Zelten, is that it is the first of the many episodes that succeeded in sort of turning economics into an experimental discipline. So let me stop here. There are many things I could say about various parts, and luckily I've wrote quite a few papers about various parts of the longer story. Perhaps for this type of audience, the best paper to go to is if you have troubles with getting rejected, then the paper Rejecting Rejection, Seeking Acceptance of External Economics in Economics Journals details in very detail how Charlie Plott sort of fought the referees in the 70s and the 80s, and how he came up with a number of strategies how to respond to various claims like you're using just students, or you're using artificial environment, and how it's not the problems that you would label external validity or internal validity problems and the like. So let me stop here. Time is tight, and looking forward to the questions and the comments.
Thank you very much, Andre. I will definitely check out that paper on how to get through review, right? So it's very useful, obviously. Now, our first discussant is Sigrid, but before I give the floor over to you, I'd like to also remind the audience that we are very open to questions from the audience, right? So if you have any questions, please put them in the chat. And when we have some leftover time from the talks or the discussants, then we will be turning to your questions very gladly. But before that, we have our first discussant, Sigrid, and then Andre has a chance to respond.
Okay, thanks a lot, Hannes, for inviting me to this session. Very interesting, I think very relevant also at this point in time. And thanks to Andre also for his interesting paper on the experimental turn in economics. So I'm not gonna repeat or give a summary of the main points of Andre. But in general, I think the paper provides a really interesting historical view on the onset of experimental economics, building on also some of his other work, right, where he zooms, I think, more closely into really the period where it all started. And what I think the main point I remember from this paper is that experimental economics actually really broke through, or what Andre calls the experimental turn, is at a point where, you know, there was a divide between empirics and theory because of all kinds of problems that connect to, you know, natural data, endogeneity problems, noise, and so on, a lack of control, basically, which basically made econometrics like deviate a lot from theory, and that's where there was a role for gathering control data. Okay, so let me share a couple of thoughts I had and questions on your paper. So the first thing I was wondering is how you actually define experimental economics. So you don't really give an explicit definition, and I think that would be really helpful in order to understand also like some other thoughts that you share with us in the paper. The way I have interpreted is that you actually refer to Vernon Smith's induced value theory in order to define the field. So, I mean, that's fine, of course. I mean, that's one way, but it kind of has the consequence that it would rule out experiments, for example, on other regarding preferences, you know, more like these behavioral economics types of experiments as part of experimental economics. I think in the history of experimental economics, this is like the typical approach, right? Then second, I mean, also kind of relatedly, I think to the first comment, so why wouldn't you consider field experiments and even some RCTs as part of experimental economics, at least to the extent that they, you know, satisfy induced value theory, or maybe not. So you focused really on the experimental turn of, let's say, lab experimental economics. I think that's really a big focus. But if you look at the data on publications in top journals, like the work by Nikos, for example, and some of the things that we also worked on as part of a data committee, well, you see that there's really a sharp increase in field experiments. The share of field experiment published in top journals and RCTs, that starts around 2000, and then it's kind of almost increasing exponentially. And this increase is really much larger than the increase that you would observe at the end of the 80s in lab experiments. So could this be another experimental turn in economics, right? Because you argue basically that economics really becomes an experimental science, you know, at the end of the 80s. But yeah, I wonder whether you can really make this claim already then. I mean, it's in the end, it's still quite a relatively minor share, I guess, of the bigger journals that have papers published using experimental economics methods. And then, yeah, I'll skip this comment. So I'll go to the next one. So what I was, when reading your paper, what I found really interesting is the comparison that you make between how econometrics arose, right? Basically, in some sense, from the same needs, namely to have empirical evidence, right? Or empirical tests of the theories that were all around, or at least the assumptions made in the theories. So I think it would be really interesting to flesh out how the onset of experimental economics and then also the evolution of the field compares to that of econometrics. For example, you could, I don't know whether these data are readily available, probably not, but this is something that an Aarct can maybe do. You could look at the share of econometric papers in top journals in the 1930s versus that of experimental papers in the 1980s, for example, and see whether there's parallels, whether they also had you know, maybe a head start and then later on was more difficult and so on. You could also look at the journals, maybe you know, try to see some parallels in the evolution of these journals. Econometrica that started somewhere in the 30s, I guess, versus experimental economics that started in the 90s. So that's basically it. So congratulations and good luck with the paper.
Thank you, Sigrid. Andre, your response.
Well, thank you so much for all the comments. There are so many questions, so I will non-randomly pick the one that I like the most. The definition of what is experimental economics and the relationship, say, to other episodes of what I say is history of experimentation, especially RCTs. Yes, in the 1970s, you have the first RCTs, you have field experiments by others, but there is little interaction. And when you look at the participants of the ASSA conferences, even today, there is little overlap between those two communities. It's very similar to what happened between experimental economies and behavioral economies, since the late 1980s, they were sort of diverging from each other. And so it's based on some sort of empirical or historical observation of these two communities. And the claim when I make that economics became an experimental discipline does not imply that everyone was running experiments. Like when theories do not run, when theories do not do any econometric work, does not mean that economics is not predominantly an econometric, or does not use econometrics as a way of handling data primarily. So, but yes, the share of experiments never sort of reaches like more than 50%, not even 35%. So, but it's the original views of early pioneers of experimental economics was that in the end, or sooner or later, all economies will be doing experiments. That has never been materialized. So instead of sort of revolutionizing economics and turning into a truly experimental discipline where everyone is doing experiment, it became a quite influential field within economics with its own sort of traditions, identity, and practices, which is sort of has better and worse days. So RCTs are more popular these days, and but experimental economics sort of includes, of course, other regarding preferences. Sort of, I identify experimental economics as sort of whatever you do in laboratory, not necessarily in the field or outside the laboratory. And the laboratory is evolving. Like this year or last year, 2020, people could not come to the laboratory, but sort of the lab came to the subjects in a way. So I'm not sure how much time I have, because when
actually.
Okay, because once
So
I get steam, I can talk about it for a long time. So let me stop, unfortunately.
All right, thank you, Andre, for your response. So we have no time left for questions from the audience, but the audience, please remember to post your questions in any case. And we're moving on to the next presentation, which is by Yanis.
Yes. Okay, so can anybody see my screen?
Yes.
Okay. Then, yeah, thanks, Andre, and thanks everybody for coming. My topic is geographical concentration and editorial favoritism within the field of laboratory experimental economics, and my co-authors are Matthias Greif and Hannes Rusch. We have 3 research questions. First, where is the research conducted and how has the geographical concentration in our field changed over the past 20 years? Second, how is this research conducted? Are there common methodological standards on how to conduct an economic experiment? Or are there differences between regions or between traditions on how to conduct economic experiments? And last, do journal editors treat all authors' papers in the same way, or is there evidence that papers by authors with a short distance or with social ties to the editors are of lower quality? Okay, just some brief notes on our dataset. We have collected data from all papers which exclusively used laboratory experiments for data generation. So we have a total of 596 papers, and these papers were published in the American Economic Review, 145 papers, in Experimental Economics, 410 papers, or in the Journal of the European Economic Association, 41 papers. And our period of interest is 1998 until 2018. So let's first take a look on the geographical concentration. Here we focus on AER and experimental economic authors, because here we use impact factors, and impact factors for the Journal of the European Economic Association have only been available since 2011. So several studies show that a large but declining share of research in economics is produced by US affiliated economists, and therefore we expect that the geographical concentration in our field declined as well. We examined the development of geographical concentration using data on countries where authors were affiliated at the time of the respective publication in our dataset. And we use a common methodology. And for each paper, we take into account impact factors and the number of authors. The relative share of research output of a single country is then given by the absolute research output of this country divided by the sum of all countries' absolute research outputs. So here we see our results. So here we see shares. The blue area here is the US and the gray area is Europe. And we have divided the full period into 4 periods of 5 years each. What we see is that the US started with a high share of research output of 65.92%, but the US's share of research output decreased to 36.79% in the most recent period. And this decrease is mainly driven by an increase of the share of research output of Europe. So Europe started with a share of research output of 28.47% and increased its share of research output to 45.15% in the most recent period. So how is the research conducted? First, we take a look on ex-ante proxies for papers quality. These proxies are available prior to publication, so they can be used by the referees and editors of a journal when deciding whether to accept or reject a submitted paper. Our choice of these ex-ante proxies here is based on 2 criteria. The variables should be related to the quality of the experiment included in the article, and they should be objectively measurable. This table here shows our 4 ex-ante proxies. So where these numbers were indicated, we collected data on the number of participants, the number of participants per treatment, the number of treatments, and the strength of monetary incentives, which is just the payoffs per person per minute in US dollar of 2015. And what we see here is that these values are higher for the AR and for experimental economics compared to, for the AR and for the Journal of the European Economic Association compared to experimental economics. So are there clearly defined methodological standards? If there are clearly defined standards, we would expect to find no differences regarding the ex-ante proxies between experiments conducted in North America and Europe, the two regions where more than 83% of experiments were conducted. This table here shows the number of participants per treatment, and we see that experiments conducted in Europe have significantly higher numbers for participants per treatment, and the differences here are significant for all three journals. The difference is most pronounced for the AR, so experiments conducted in Europe and published in the AR have twice as much participants per treatment compared to experiments conducted in North America. We also find significant differences for the number of participants for AR and for experimental economics papers, but we do not find significant differences for the number of treatments and the strength of monetary incentives for AR and JEA papers. But for experimental economics papers, the strength of monetary incentives is significantly higher for experiments conducted in Europe. So now we focus on ex post quality proxies, and here we use citations. The ex post proxies measure the quality of a paper after the paper has been published. And of course, citations are only a proxy for a paper's true quality, but data on citations is widely available, for example, on Web of Science or Google Scholar, and citations are regularly used in studies similar to our study. We have seen that North American and European experiments differ with respect to the number of participants and number of participants per treatment. And if there's a positive correlation between these two variables and the experiment's quality, we would expect that European experiments receive a higher number of citations on average. In the following, we use Google Scholar as our citation source. These figures here show citations per year for experiments conducted in North America, the upper three figures, or experiments conducted in Europe, the lower three figures. And what we see is that experiments conducted in Europe, when published in the AR or in experimental economics, receives significantly significantly more citations per year on average. But we do not find significant differences for JEA papers, but here we only have a small number of observations. So our third research question is on editorial favoritism. Editorial favoritism implies that editors and co-editors of a journal favor papers by authors to whom they have some social ties over papers by authors without these social ties. Our assumption here is that papers from authors without social ties must be of higher quality in order to get accepted by a journal. And as a result, these papers should receive more citations in the years following publication. A further assumption is that the probability for social ties is higher when editors and authors have their affiliation in the same country. Our hypothesis is that the larger the share of US affiliated authors on an AER paper, the fewer citations this paper attracts. And we hypothesize this exclusively for the AER because almost all editors and co-editors of the AER had their affiliation within the US or at least in an English-speaking country, and this is not so much the case for experimental economics or JEA editors. We measure editorial favoritism by using an OLS regression. Our dependent variable here is CI, the total number of Google Scholar citations. And in our regression, we only include papers published before 2017, just to ensure that each paper had at least 4 years' time to receive citations. Our measure for social ties, or our proxy for social ties, is ST. And here we use the share of US authors or a measure for the collaborative distance between editors and authors. So in our regression models, we include ST and interactions for ST and AER papers and an interaction term for ST and JEA papers. So AER here is a dummy which takes a value of 1 if the paper was published in the AER. And the parameter H here is years since publication. And then we have 3 additional vectors. E is a vector containing the experiment's quality characteristics. So these are the ex-ante proxies. P is a vector containing paper's quality characteristics. So for each paper, we have the number of pages transformed to experimental economics equivalent page numbers. We have the number of references for each paper and the GEL classification. And A is a vector containing some more author characteristics. So for each paper, we have the share of female authors and a measure for author's reputation. Here we use the average number of citations the author team received in the 5 years prior publication, and we also control for the number of authors. This table here shows our results. So here ST is the share of US authors. In model 1 and in model 4 here, we do not control for the 3 vectors E, P, and A. In model 2 and in model 5, we only control for the experiment's quality proxies. And in model 3 and in model 6, we control for all 3 vectors. So when we take a look at model 1 and model 2, we see that the interaction for share of US authors and AER papers has a large, significantly negative effect in model 2. And we also see that the interaction term for share of US authors and JEA papers has a significantly negative effect on citations in model 1 and in model 2. In models 4 to model 6, we have dropped some outlier papers. So these are papers where the number of citations is higher than the mean of citations plus 3 standard deviations. So for example, we dropped papers by Holt and Laurie and by Ernst Fehr and Simon Gechter. And what we see is that the share of US authors has a significantly negative effect here in model 4 and in model 6. And the interaction terms, for the interaction terms, we see that share of US authors for AER papers is significantly negative in all 3 models. And this is also the case for the interaction term of share of US authors and JEA papers. But here we have to say that the share of US authors is a comparatively weak measure for social ties. So on the next slide, we introduce a new, better measure for social ties, the collaborative distance between editors and authors. What have we done? We have calculated all co-author distances between the 68 editors and the 931 authors in our dataset at the time of the publication of the respective paper. Our calculation here is based on 450,000 unique publications published in the last 70 years in 1,434 journals classified as economics journals. And these papers were written by 268,000 authors. So each author in this network is one node. And when 2 authors have written a paper together, there's an edge between these authors. And so we have a dynamic network which enables us to calculate all co-author distances between editors and authors in our dataset. Our resulting alternative measure for social ties is ST, the min dist. So it's the minimum of all distances between all authors and all editors. It's a continuous dynamic measure with values for each publication year. This figure here illustrates min dist. So when the editor herself here has written the paper in our dataset, her min dist is 0. And if a former co-author of this editor has written a paper in our dataset, her min dist is 1, and so on. Okay, this table here shows the results. So now the measure for social ties is min dist. And what we see is that min dist has a significantly positive effect here for AER papers. And this implies that papers written by authors with a larger distance to the editors of the American Economic Review receive significantly more citations in the years following publication. When we drop the outlier papers, we see that min dist has significantly positive effects also for JEA papers. And this effect here is significantly positive in all 3 models. So our conclusion is the geographical concentration in the field decreased. European experiments rely on a significantly larger number of participants and a significantly larger number of participants per treatment. And this difference is most pronounced for the American Economic Review. Experiments conducted in Europe receive more citations compared to experiments conducted in North America. And our results based on the share of US authors show that there are at least signs for a bias towards US authors. So I have to say that we do not say that editors consciously discriminate against authors outside the US, but we say that they systematically mispredict the number of citations a paper will receive. And our results based on the MINT-DIST imply that AER and JEA papers written by authors with a smaller co-author distance to the editorial board receive significantly less citations compared to papers written by authors with a larger distance. And we interpret this as a sign for editorial favoritism. In the following months, we will collect some further CV-based data to identify additional social ties so that we are able to check for social ties on the institutional level. So that's it. Thank you very much. And now I'm really looking forward to the discussion of Sherry Lee and to your questions.
Thank you very much, Janis. You were perfect on time. So I'm giving the floor directly over to Sherry for her comments.
Thank you very much. So Janis, if you can unshare, I can go ahead and share my screen. All right, share the screen with you guys. So can you guys see my slides? All right, thank you very much for inviting me to discuss this very interesting paper. I enjoyed reading it. So I'm not going to spend time summarizing the paper. I'm having a little issue with transition my slides again. I don't know what happened.
I think you're, sorry, Sherry, I think you're sharing your entire screen and not the presentation.
Now the presentation. Okay, so try one more time. Sorry about it. Okay, let's see. I'm not going to share, I'm not going to talk about the summary. So lots of things to like about this paper. So it's a very ambitious project and it asks very important questions, and it actually coincides with ESA's data committee's effort in investigating how and why economic research using experimental approach has changed over time. So I just have some thoughts. So the first thought is about why in the study only focus on lab experiments. You know, I get it. So the main advantage is to ensure the comparabilities, again, you know, making apple-apple comparisons across studies as mentioned in the paper. What I see, the flip side here is that the paper may be missing an important part of the big picture. So let me digress just a little bit by talking about ESA Data Committee's effort doing a similar investigation. So again, Sigrid and Andre and a couple of other experimental economists are all involved in this effort. So we look at a sample of 7 journals alphabetically ordered here: AER, Econometrica, and EJ, JEA, JP, QJE, and ISTAT from 2000 to 2020. So our samples actually overlap quite a bit. And we're still updating our data, but some preliminary findings include traditional lab experiments has declined in AER and remain somewhat rare, still rare in other top 5 journals, while there is an upward trend in JEA and EJ. And I don't think this is, this results will change. Another important result is other type of experiments, including the combinations of a lab and other types of field experiments, have seen a consistent increase. I was debating whether I'm going to put the pie chart here, but because of time, I'm going to skip it. So I guess my point here is this flip side of focusing exclusively on the lab experiments with college students is maybe missing, another important component of the rapid growth of the research that use or combines with other type of experiments on non-student sample. So I would like to talk about the measures on scientific quality and social ties. I really appreciated the author's enormous effort in coding the data, because I know how this, how much time it would take. And, I appreciated the information, enormous amount of information that they include in the paper. However, I can't help but be concerned about, relying on, for example, number of subjects per treatment, number of treatments, and citations entirely to draw connections or inferences on quality. So number of treatments may be determined by, research questions itself, right? And number of individual participants, is that a good measure for quality? Folks may think otherwise, because when you think about the independent unit of decision-making, depends on your design, whether you study individual decision-making or it's a dyad decision-making or it's a multiple people group decision-making, right? And I would maybe look more into the data to see whether you can code the number of independent decision makers to see whether your results are still robust. Number of citations.
Sherry, I'm
again,
sorry, I have to ask you to be a bit quick towards the end now.
Sorry, is that a question?
No, I'm just saying, please try to finish quickly now.
Oh, okay, I will. Yes. So citations, there are some bigger fields than smaller fields. Again, if you open any of the conference programs, for example, there obviously there are more, for example, sessions than on some topics than other topics. So very quickly to finish it up. So I have no issue of reporting the results. I think it's very important information to have, but I would be a little bit more careful about drawing, inferences from the these measures and results on these measures. Last point, I think the big challenge here, on the quality and also editorial favoritism is you're looking at basically the numerators on conditional on publications. I think, more work needs to be done to say more definitively about the quality and favoritism, by looking overall the picture, especially, I don't know, we have the data, of course, in the pool of the paper submitted. I have some minor things I'll just send to you, offline. Thank you so much.
Thank you, Sherry. Yannis, very quick response, like 30 seconds.
Okay, so thank you very much. Really good points. Let me just address some points. So you questioned the effect of the ex-ante proxies on quality. So I haven't included the results for the ex-ante proxies here, but what we see is that the strength of monetary incentives and also the number of participants per treatment has a significantly positive effect on citations. So based on these results, we see that there is some relation between these proxies and the paper's quality as measured by citations. Your point on independent observations, yeah, we addressed this point in the paper, but there's no clear definition what constitutes an independent observations. And for us, so we thought about identifying independent observations, but it's really hard when you have, for example, a public good game with random matching over 20 rounds. So then it's really debatable what constitutes an independent observation. And on your last point, yeah, unfortunately, we don't have data on submissions. So yeah, we have to focus on published papers. But maybe that would be one interesting point for a follow-up paper. So thank you very much for your points. Okay.
Thanks again, both. And we're moving on to Jonathan. The floor is yours.
Great. Thanks so much. I'm very happy to be presenting my work on research registries. This has been joint with Elliot and John, who've been a lot of fun to work with. And what we do in this paper is a theoretical and empirical examination of research registries in general and the AEA RCT registry in particular. So I imagine many of you may be familiar with the AEA RCT registry, but just so that we're all on the same page, what it basically is a venue where researchers, when they're conducting an experiment, can document the treatment arms and their results. So the way I like to think about it, or the motivation for including having this initiative, is to decouple the publication and the dissemination of research. We've probably heard about, publication bias and all these sorts of biases that kind of emerge in terms of the published findings through this publication process. What a registry does is allows researchers to say what they're doing kind of independently of what's happening in publication. So in terms of why a researcher may register, I basically can divide the benefits into two categories. So the first is what I'll call a private benefit, which is the benefits that are incurred to the researcher when they're registering. So you may think that, describing the treatment arms before conducting the experiment kind of adds a degree of credibility because it allows you to say that you didn't select the treatment arms on the findings. So it provides a kind of source you can go back to say that you're not kind of having this potential source of bias. And we also think, it may just be helpful for researchers in terms of thinking through exactly, what are kind of the important treatments may encourage some added care to the design of the experiment itself. It also has a benefit of allowing some journals, the AEA journals require registration to be submitted to, but I'm going to come back to that benefit in a second because it's the details of that are important. In terms of the public benefit, we think of this as kind of as creating a record of the documented conducted experiments that have been done. So a policymaker kind of interested in, if they see a catchy finding, they would be able to look at this registry and see, is this just the catchiest finding that was there? What is kind of the, or just to create a more representative sample of what's been done. So I want to point out that it's different from a pre-analysis plan. So it's not necessary to describe what you're going to do in the experiment. So that's kind of the main distinction between the two. Although obviously I can't, if I'm just saying I'm running an experiment, that's not really that much, that's not really meaningful. So you have to have some level of details to have any meaning, but it's not quite at the level of the actual data analysis. So in the paper, we look at how, both from an empirical side and a theoretical side, how registries tackle the file drawer problem, which is this idea that results may be found and then put away, as well as the p-hacking problem, namely that, the fact that researchers may have this temptation to, modify the treatment arms after the after seeing the results. Okay, so first part is it's the paper's taking stock and looking forward. So taking stock is the kind of empirical part. And overall, I would characterize our tone about how effective the registry has been as fairly negative. So one thing I mentioned, there's this requirement to register an experiment in order to be published at AEA journals. But the experiment is first only the requirement is only for field experiments, and second, more importantly, I think the requirement only applies that only says that it has to be registered at some point. So I think a lot of the benefits I was talking about implicitly assumed it was done before the experiment. The fact that I can't select on the findings, well, that only really means something if I don't have the findings yet. But we actually find that a lot, and so, but there is this option to register after the experiment has been conducted. And we actually do find that around half of registrations are after experiment completion. So let me just show you these time graphs very quickly. So I don't want you guys to stare at this, too much. But what we find when we look at the registration rates, that roughly half of them are late. And that also importantly, that the number of late registrations has roughly been growing kind of in tandem with the number of early registrations. So even though there's this option, it does seem that there are still, there are still a lot of these registrations that are kind of done after the fact. So we also do a census of published experiments and find roughly half of these are not registered at all, with an even lower share being registered early, although here we run into a slight issue that there just aren't that many papers that have been published that were kind of conducted after the start of this registry, which was only in 2013. But still, we're still not finding, even among those, we tend not to find all that high a preponderance of papers that are registered or pre-registered. So the second part of the empirical, the second part of the empirical analysis is we try to analyze actually how informative are the registrations themselves. So we took a sample of these pre-registrations and had a team of RAs kind of evaluate their informativeness on a scale of 0 to 5. And we had talked more about this in the paper, but just to kind of tell you what we find, we find 2 degrees, roughly 2 degrees of description on our scale. And concretely what that means is that if you think about, an experiment on nutrition, okay, what you would expect a registration to say is that they would be looking at the number of fruits consumed. Okay, so that's what 2 degrees of separation means in our rubric. They're not saying number of apples consumed in X time frame in Y location. So that would be a 5 on our rubric, inclusion of the time frame and all these other things. So it's quite a bit below that kind of, I think, idealized benchmark. Now we do find that plans are somewhat followed, but they do, and so that's maybe not so surprising given the amount of latitude that they have. Although it is, on the other hand, it is true that if you see something about fruit, it probably is about fruit consumption, but there are many papers that do add outcomes as well. So that's our kind of assessment on how how effective is the registry how effective are these registrations at tying the researchers' hands. Now, one question you might have is whether, well, is this just because economists are idiosyncratic, or what's kind of driving this? So we do replicate our analysis on clinicaltrials.gov, which is a large, kind of actually the largest registry that's out there, although not for economics. And we find, roughly similar patterns. They're slightly more informative in clinical trials, but broadly the findings that we have are in line with, we don't find a major description, which we kind of attribute to an issue with the registries in general, and not necessarily just the design of the AEA registry, or not economists or whatever. So I realize we're slightly behind time, so let me be very quick on the theory side, because I do want to mention we have a theory model. I mean, I'm a theorist, so I have to make a big deal about this. We have a theoretical model of registration, and because this timing issue is, I think, so concrete, that's sort of the main one we focus on and try to speak to. So we have a theoretical model that has this dynamic element where researchers can decide when they register, namely whether they register based on some initial signal, which is unobserved, or register based on a second signal, which is kind of the publication finding. So that was very, very quick. I apologize in case that didn't make any sense. The main point of the theoretical model, which I think hopefully will make sense, is we identify that late registration can come at the cost of early registration. So you may think that just allowing for more opportunities to register could only increase the number of registration because maybe a researcher forgot, and so it's just another time in which they can register. And so that may make you to think that, well, yes, allowing late registration is great. What the model highlights is there's this other effect that researchers may find that, if they're kind of on the margin between registering and not, this ability to register late may kind of induce them to delay their registration. And in fact, there's a theoretical result that actually that may lead to lower amounts of registration overall, early or late. So, basically having this option could in fact, decrease the number of overall registrations in kind of some extreme case. So that's a theoretical result. And I think with all theoretical results, your first thought is like, well, who cares? So we actually have a calibration of the model to show that there are parameters of it kind of matching the broad patterns we see where this does happen. Okay, so not only is this a kind of a theoretical result, but I would say it's also kind of an empirically relevant one, because we are able to show under sort of reasonable model parameters that this would happen. But you'll have to trust me, because I can't say more about the model than that. Although we do talk about other incentives. I don't want to say it's only about allowing late registration. We also kind of highlight some other interesting kind of trade-offs between encouraging registration or encouraging experimentation and allowing for late registration. And we also suggest that kind of linking these IRB applications to registration may be a way of kind of having the best of both worlds. So that's another kind of policy prescription we talk in the model. So so let me hopefully we can catch up a little bit. I just want to say one last thing to conclude. I think one thing that I think was in Andre's talk was that there's lots of fields that have cared about these kinds of questions of statistical methodology or like experimental methodology. In many ways, economics was kind of late, I think, to the game in this dimension. And so we're not the only field that thinks about these methodological questions, but I do want to say that I think where economics has a comparative advantage in speaking to methodology is the fact that we are kind of experts or focused on questions of incentives and institution design. And I think that kind of one place, this is, so as I said, so there's lots of fields that would care about these kind of methodological questions. I think where economics kind of is uniquely positioned to speak to them is in terms of speaking about research incentives and then thinking about the research kind of institutions. And so one kind of way of one kind of interpretation of this project is making this concrete in the context of this AEA RCT registry. And I think our main message is that these solutions to these methodological issues are both challenging and important. And so that's, I think, the most important message, I think, to take away from today. So thanks so much, and I'm looking forward to the discussion.
Thank you very much, Jonathan. That was perfect timing, even 2 minutes ahead of time. So let's move to Matthias' comments.
Okay, I'm gonna share the screen. So what are you seeing? Do you see the slides?
I'm seeing like all three of the slides. It was a thing that we had.
So now?
Oh yeah.
Okay, so thanks, Jonathan, for giving this paper. I will be brief because we are behind the schedule. Just imagine the following situation. You run a study and then you get inconclusive results. It's not easy to tell a good story to convince the editor to publish the paper. So basically, there are two ways to go now. You can abandon the project and put it into the file drawer. That's the first option. The second option is to basically reanalyze the data to define some data points as outliers and drop these observations, and then repeat this until you get a nice positive result, which allows you to write up a nice story and submit the paper. Of course, both ways are problematic, and what is done in this paper, or what is where the registration issue comes in, is how to solve these problems. So pre-registration can solve these issues, and this is why this paper is really an important contribution to growing literature about open science and pre-registration. So there are two main implications which are derived in the paper. The first is that
I don't know if you've been changing the slides, but are you? I think my screen isn't changing.
Oh, okay. So
there we go. Yeah.
Yeah. So there it is. There are two main implications. Which, the first is that by removing the possibility to register late, you can increase the share of registered experiments. And the second implication is that you can lower the cost of pre-registration by linking the registration to the IRB material. And in this way, you can also increase the number of pre-registered experiments. So I completely agree with these two implications. But let me just raise one point which is really not clear, at least not clear to me. And this point is related to the first problem, to the so-called file drawer problem. It is, to me, not clear how registries can solve the file drawer problem. Because if you assume that all experiments pre-register and that all pre-registrations provide sufficient details, so there's no issue with p-hacking, I think this is not enough, at least to solve the file drawer problem, because you need some additional assumptions. Either you have to assume that the pre-registrations somehow increase the publication rates for papers which report negative or inconclusive findings. And this is, I think, contradictory to the assumptions that you make in the model. Alternatively, you could assume that the results are stored in the registry. So people can go there, look up and look for your results. And then you need to assume that the registry is used in the same way as published papers. So it's basically on par with JSTOR, which I think is not very realistic assumption because there are these quality differences. There's no peer review if you put your results in the registry. So I'm wondering how pre-registration can solve the file draw problem. And related to that, this is the second point here. Sorry for that. You see the slide?
Mm-hmm.
Yeah? No? So the second point, I don't know what you see. Second point is that there might be a file draw problem in the registration process, because if you register late, then you only do this if you are on the margin according to your first signal S1, but then you register late if your second signal S2 is high. So if this is really true, then there should be a systematic difference between early registrations and late registrations. So you would expect basically more positive outcomes for experiments that register late. So I was just wondering whether you can see this pattern in the data. So thanks again for presenting this paper, and I hope we are still on time.
Yeah, we have 1 minute for a response by Jonathan.
I think those are great comments. You know, let me start with the second one. I think that's sort of a very natural natural conjecture. I think in order to speak to it too, convincingly, we would kind of need to see what are the informativeness of the non-registered, non-published experiments, and so there's a little bit of a kind of challenge on that dimension, which is why we don't say much about it. In terms of the file draw problem, I sort of agree it's the second best. It's definitely a second. Registries are a second best solution. I think this is one of the. I think the fact that you kind of keep the registrations to be very simple is kind of designed to be one way of helping people who are kind of interested in just observing what are the results, kind of helping them interpret it. But I agree, there still is kind of an intention problem and a kind of a finding what's in the file drawer, or finding what's in the registry problem. It's hard for me to know of a kind of a better way to address them, but that's for sure something that's worth thinking about.
All right, thank you, Jonathan. Very good in time. Then let's move on to Gary for the next talk.
Hi there, can you see that?
Yes.
Good. Slight title change, the journal butchered the paper. Anyway, we added what is considered deception in experimental economics. Let me just summarize the paper in like really short, like a minute, and then I'll get as far as I get. So why did I do this paper? Well, I got annoyed because there's such a variance in views on what is deception. You're an editor, you get a paper, you send it out. Referee says, this is deception. You go back to the authors and they say, what the hell are you talking about? And some of these guys have been around for 30 years and there's just a disagreement about it. And it's not about explicit black deception. There's a lot of gray areas that it's pretty much undefined. So I wanted to see what the attitudes were out there among the people who run experiments about what is deception. So I took a lot of gray areas and asked questions about it. The bottom line on what we found is that there's a great deal of variance on what is considered to be deception. Gray areas, there's a lot of different views. It's also true among students. Students have some different views. Most remarkable thing with the students, though, I thought was that something like 83% didn't know that there was a no deception policy at their school. So that's the bottom line, is that it's really, there's a lot of disagreement about exactly what is deception. And my main point from this, it would be nice if reviewers would lighten up a little bit, or if we could get some kind of standards that people would accept. So, and now I'll proceed into my talk. So that's an overstatement, almost religion, but it kind of is. What is deception? Nobody knows. All right, you can't lie, but what are these gray areas? So we do this large survey. And you could almost say that I was deceptive in running the survey, because I sent out the thing by mail merge, and mail merge makes it look like everything is a personal email, and it's not. So maybe that was deceptive in there. But we got over a 50% rate of response. I sent it out to 1,554 people. There were people on the experimental economics list in REPEC, the top 10% supposedly. I don't know that. And we did it with students as well. Okay, specific gray areas, lots of heterogeneity. We have 7 specific scenarios. We also find something that David Cooper brought up in an article some years ago, that costs and benefits matter. So if something's really important and you can't get at it any other way, maybe it's all right to do it. This is not a lexicographic thing. You have to consider the situation. The students have different attitudes. Mainly they care about if deception affects their pay. As long as it doesn't affect their pay, they don't seem to care about it. So again, as I said, someone says this is deception, the authors don't agree. You want to maintain experimental control. You want to avoid negative spillovers. You don't want people to think that you're deceiving them. At least that's the view. Although if they don't even know there's a no deception policy, it's a question of what we're really doing. So old stuff, people say you can't use deception. That's the party line. What are the actual attitudes? That's what we try and find out. Okay. Big deal survey. Okay. We also did stuff with students. We didn't define deception. We don't know that we're supposed to define deception. We just asked people to rate levels of deception in different common scenarios. Okay. There is related literature. I'm not going to really go through it. You see the names up there. The closest is the Mikhail Kravchuk paper, which we didn't even know about before we started our survey. It has a lot of similarities. We go a bit deeper, and ours is bigger, of course. But something that actually is no longer in the paper, thank you, editor. But this is a study by psychologists, and they actually find that their students are not bothered by deception, and they actually find that the students seem to think that economists are more deceptive than psychologists, which was very weird, but they are psychologists, so maybe that's part of how they found that. We expected this strong view that all this stuff is bad. We don't get it. 73% of the students are unaware of the no deception policy. Many of them state that they're likely to return to the lab even after knowing they were deceived in an experiment. So exactly what are we protecting against here? It's not really that clear. So this paper will cause trouble, of course. Differences in opinion, I said that already about costs and benefits. I think this is comforting that it's not lexicographic, okay? So in most of our gray area scenarios under this condition, about half of the respondents felt the deception would be mostly appropriate. There still may be selection bias, so we can't really make definitive conclusions about this. Tim might actually be here. Okay, some very simplistic policy recommendations. It's a really good idea to make potential subjects clearly aware of this no deception policy. Of course, you don't want to hit them over the head with it, but it seems to me it would be a good idea. The reason behind the paper is I'd like to have some sort of a more nuanced view and take account into these costs and benefits and see what really works. And maybe even more so the third one, I'd like to see people refrain from calling things deception just because they think that they don't like it. There isn't a consensus out there. People have said to me, why don't you make your views known to games and economic behavior, where I'm an editor, and define a policy? Well, I don't feel like I have the right to do that. I think this is something for the field to decide. But I think that something could be done about it because I get tired of this. Maybe everybody does. Maybe some of you have had papers rejected because someone said it was deception. So what did we do? We used this list. We we sent it to 1,554 people. We got 700 responses. We got these responses, actually better than that because about 65 of them bounced. We have background. We have questions about views of deception. We have different scenarios. We paid something like 3 people or 4 people $100 rewards drawn randomly. So these are questions that we asked them. We were trying to figure out responder beliefs about whether it's unethical to deceive in experiments, whether there's a potential loss of control due to deception, and whether that's a serious problem, whether it's important to avoid deception, and whether deception can be useful. Here are the actual questions, which I can't imagine you're going to be able to read. Let me pick one. So you may not even think this is deception, but here. Participants in experiment are told that there will be 10 periods in the session, but are then told that there will be another 10 periods. That's a surprise restart. Everybody does it. Well, you didn't tell them something that was germane. Is that deception? I don't personally think so, but some people might think it is. Non-representative sample. So this is actually what started this paper, because I have a paper that I joined late. And so you tell the participants the average value of the choices of beliefs of a sample of the other participants, but you don't mention it's not a representative sample. And in other sessions, you state different averages because you're taking different subsamples of the population. Is that deception? There's a better case for that one. It's not obvious to me. So these are some of the different ideas that you can have. Here's one that I've used a lot, and I like it, but it could be deception. The first one, subgroups. In a multi-period experiment, you tell the participants that they've been randomly matched every period, but in fact, they're only matched within subgroups. More independent observations. This is the Sultan idea. Could be considered deception. So these are some gray areas, okay? This is, all I'll say about this is look at how much variation is in here. There's something in every one of these cells. And there are differences across these things, and I'm not going to get into it. I guess the avoid is the highest one. So people do think it'd be nice to avoid deception, but they're not so bothered by, I don't know if I have these right. Let me just say that there's a great deal of variation in responses. The view that deception is unethical is not universal. At least 60% of the people say at least 5 is not unethical on this scale. 75% of respondents feel that deception results in loss of control. I do too. 84% of respondents feel that deception should be avoided. I do too. Sometimes it might be necessary though. Richard Thaler, who I'm not the best friend of, but before he won his Nobel Prize, he made a statement at the UCSD Spring School. He says, I don't know what the optimal level of deception is, but I'm pretty sure that it's not 0. I agree with him. It's rare, but I agree with him. Anyway, these are I'm not going to keep going. We have different views here. These are just numbers. They basically give you what it says in the chart. Some little things though, so you don't see differences across position, full professor, graduate student, associate professor. And this surprised me. You don't see much difference here across field and lab. You really don't see much difference at all. This is more surprising between the bottom 500, middle 500, and the top 500 in the REPEC ranking. Here's an editor, here's reviewer. There really isn't that much difference. I was rather surprised. You do see some difference. It's the same sort of thing. I'm not going to get deep into it. I'm going to give Nikos a chance to actually talk since he's staying up until 3 in the morning, and I'm going to be brief. But you can see that there are some differences here. Not that important. This kind of chart, oh, this isn't in the paper anymore because we had to take it out. But this is when you look at the different countries, and 4 is not necessarily neutral, but it's the middle of our scale. So this is what we see. Mean ratings by researchers at the different scenarios, and you see differences. I'm not going to get into it. Researchers' ratings of the scenarios, you can see it better here. You can see that there's a real range. It's not like everything is piled up on one end or the other. It's just not. I'm skipping this. I'm skipping this. Just the same story. Student results. So we did something a little different. We also went to the students. This is a little tricky. First, I wanted to do students that had graduated so they wouldn't be affected. And then I was persuaded we should just do students. So I did more students. The students perceived deception is much less unethical, mean rating of 2.6 versus 4.68. And I think it's much less important to avoid it. They just don't care. On average, they're more lenient. In some cases, they are bothered more when it has to do with their own money, okay? Students from the US labs find deception less unethical than students from the UK lab. I don't know if that means anything. Student attitudes towards deception, you can see they're more to the left than the researchers' views were. Students' ratings for questions about deception, once again, you see that there's a real range. There is no real consensus here, either among the students or among the researchers. How much time do I have?
3 minutes. 3.
3 is.
3 is.
I think 3 is this.
Okay.
All right. So the results are there's a great deal of heterogeneity. Use of confederates or bots or strategic omission of relevant information they're rated as the most deceptive of the scenarios. There's more uniformity on the importance of avoiding deception. Quite a few researchers regard deception as appropriate when there's no good alternatives available. This could apply to something like, say, an audit study, which I think is clearly deception, but maybe there's no other way to get those results, okay? Students are also heterogeneous, and the thing that shocked me was they don't even know that there's a no deception policy. It's in place. Amazing. And this is even in my lab. So students are more lenient in most cases. Findings challenge the prevailing orthodoxy, which is really focused on blatant black deception. And I don't, maybe I can't say that these days. That sounds bad. Well, take the color away. The attitudes are not unfailingly negative. And that's the basic issue. I just don't understand this. And they're not so concerned about deception. If the students aren't concerned about deception, why are we so concerned about ruining our reputations when we don't even have one in the first place? That said, I'm not about to embark on using deceptions in my experiments, but there are some practices, particularly when you're trying to elicit beliefs. I think that's the worst case. So the paper I was talking about, beliefs were elicited based on information given to them about what the norm was, what the average was in the group. And sometimes if you want to see things, you could run it thousands of times and get the actual percentages to be right in a couple of those sessions, and you can report those, but that's impractical. So let me just move on. That was the end of my slideshow. I'm early. I'm sorry about that.
You're 1 minute ahead of time. Thank you, Gary.
Want to hear some jokes?
Then
Did you know that there are 3 kinds of economists? Those who can count and those who can't. And I'll leave you with that.
All right, thanks, Gary. Let's move to Christina's comments.
Great. Gary, can you stop sharing? Then I can share.
You mean verbally or on my screen?
Great. Here we go. Okay, thank you so much for having me here for the discussion. I'll get right to it. So hopefully you had more than one observation in Denmark, because I was seeing here, right, you said it's not out of the paper, but it says research from Denmark perceived deception as much more unethical. And that, I don't know if that's just me, since you said you didn't ask for country in the survey originally, I don't remember it, but you then used the IP address of the respondent as a proxy to map into her country. So I think that's already a question of, I would say that is probably bordering on deception, depending on how we want to talk about it. But that's not the main point. Overall, I think it's a very interesting paper. I mean, it's an impressive sample size, definitely, getting about half of the experimental economists on REPAC to reply to this. So I think that's great. That's definitely representative of the group. It was very interesting to see this big heterogeneity in what researchers and also what the students consider to be deception, and also their ideas of how problematic it is. It's clear that there's no clear consensus on what is ethical and for what end. So what are the costs and benefits? And I also see the problem that this is problematic for refereeing and publishing, but also when we want to think about maybe more difficult questions than some of the questions in the paper. So I don't want to go into any of the details of the analysis, but more looking at it from a general perspective of saying, if we think about deception, and you do talk about this a bit, are we thinking about this moral, ethical way of how should we treat people that we're running experiments on? What is our responsibility to not give them maybe wrong beliefs about should women enter the labor market or these type of questions? So is that part that we're interested in, or is it more the practical part of deception? If we tell them they're going to earn $5 and they just get $4, then they're not going to come back because they're mad, where that might be less of a moral question. And I think in the first question you ask whether people think it's unethical. So I don't think it's that surprising that we get quite a variation, because it can be very different as what people think deception is, and then based on that, whether they think that's ethical or not. I mean, I ran a lot of field experiments. I don't think they're unethical. So I'm definitely said, if that's what counts as deception, I don't think it's a problem. But then there's definitely things that could be a problem. And I think this is also very much in line with this idea that 17% think that deception could be useful, which I thought was quite low if you think that some people actually think it makes sense, such as running field experiments. And then we also see that the answers to the concrete scenarios are a bit more consistent. So, well, this is perhaps an answer to stubborn referees to just say, okay, people just don't agree, and that's why we shouldn't be so picky. I think what we want to think about in the long run is, well, experimental economics has evolved since, for instance, mixed market experiments and what do people get paid. So what do we have to think about now that, deception is maybe more than just regrouping people, but actually in a way running field experiments or really changing people's beliefs over many months, right? There's some even lab experiments that run over several months and get people to change education choices. So I think it's really going onto a different level. And then I was a bit surprised that in the paper you don't really discuss IRBs or ethics groups, which I would assume they are supposed to be there to think about the gray areas. I know that maybe the US is different, but at least now in Denmark, where we're trying to be more ethical, where we're just recently started having an ethics board. So I think, shouldn't we more think about what's the process of discussing what's ethical rather than trying to find boundaries of this is okay, this is not okay? I see you're not agreeing, but we'll see. So, but I would say that ethics usually is not going to provide us a yes/no answer in any case. So I think it's more important to think about what is a good process to focus on rather than trying to come up with a list of stuff that's going to be okay or that's not going to be okay, because that list will be outdated, I don't know, within a couple of months. Okay, thank you.
Thank you, Christina. Gary, you'll need to unmute before we can hear you.
Might be luckier if I was muted. First of all, this nonsense about this thing, we didn't ask for countries, but we could get the IP addresses. We figured that out later. Apparently Europeans are extremely concerned about this, whereas Americans could care less about it. So the paper originally had that thing about Denmark, it's gone. Now we only talk about the US, Europe, and the rest of the world, which I think is sort of pathetic, but to the view about introducing an ethics board or something into here, why would you want to have more going to the bureaucracies? That is the wrong direction. I do think that you have to have some consensus. I certainly agree that this is just a start. This is just a start. We're not trying to answer the question. We're saying this is a problem and it's not really what people think. I absolutely take your point about we didn't define deception, so people have a real free range about considering what they consider to be deception. So whether it's appropriate or not, certainly I agree with that comment, absolutely. But that said, there's still a great deal of difference in people's views about this, researchers' views about this. That is my main point. I don't want to propose an answer, but surely the answer is not to delegate this to research boards that don't know anything about running experiments.
But shouldn't we have research boards that know something about running experiments? So shouldn't we
You're going to get people
improve on that?
That don't do research, because if they were doing research, they wouldn't be in this bureaucracy, especially government bureaucracy. If you could have researchers govern this, yeah, that would be great. But if you're going to take it to some governmental agency, forget it. Forget it. We've had IRBs here in this country for a long, long time, and they've gotten actually more reasonable over time. They used to be just crazy, and it's gotten better. So, but you know, that's why I don't talk about IRB. IRB is completely orthogonal to this process. nobody, the students don't care what the IRB says. The students don't even know about an IRB. They don't even know there is such a thing. They just come there and they say, this is an experiment. They don't know that it's been, you know, we say this is blah, blah, but they don't believe anything. They just do the experiment and they hope to get money. So I'm very much against that, and that's why I didn't put it in. But I do think we have a real issue here. And I do think it would be nice if authors and referees didn't throw things back and forth with each other about what is deception. That is, to me, the primary thing, is at least we can take a more nuanced view. I don't know how that will improve things in the future, but it seems like a good place to start.
All right, thank you, Gary. There's a question in the chat by Catherine Eckel. I don't know if you saw it. Maybe you want to answer it while we're moving on to Nico's talk now. Okay.
Huh, I don't even see it. Well, never mind.
It's in the Q&A chat.
Oh, all right. Thanks.
So you want me to start?
Go ahead, Nikos, please.
All right, so hello everyone. Thank you very much for the invitation. It's getting close to 2:30 a.m. here in Abu Dhabi, so I hope I'll make sense. We're also dealing with a kind of a big picture issue for experimental economics, which is selection into the lab, although we're doing it in a specific context, which is basically looking at whether selection bias causes us to overestimate gender differences in competitiveness. So a little bit of motivation. Lab experiments have been used extensively to explore the existence of differences in preferences across groups of individuals. One of the most prominent examples of such research programs is gender difference in the willingness to compete. Other examples can be like, are economic students different?
Because your volume is going up and down.
Better now? Sorry about that. Okay, so now to summarize a little bit, the findings, there are two kind of quotes I have here. One is from Muriel's handbook chapter. It says, there are large gender differences in reaction towards competition, with women shying away from competition with men. These differences persist and are only somewhat reduced when controlling for beliefs about relative performance as well as risk aversion. So the emphasis I'm placing here is on the large gender differences. On the other hand, so Marianne Bertrand in her own handbook chapter in Labor Economics 2000 level, she says that while the lab evidence shows in many cases large gender differences, same attitudes towards risk or attitudes towards competition, most of the existing attempts to measure the impact of these factors on actual outcomes fail to find large effects. So there is this interest in the magnitude. In the lab, we seem to find large gender differences that could make us hopeful that we're actually picking up something with a lot of explanatory power. In the field, the effect seems not to be so big, although what is big exactly is to be debated. Now, there could be different reasons for this. The one we're considering here is that maybe there is selection, okay? And selection bias is causing us to overestimate the gender gap in competitiveness. So to kind of course, that selection bias could go the other way. It could cause us to underestimate. But what we did is we took a look in the literature and tried to classify all studies that use the design of Niederle and Westerlund as those that use self-selected samples and non-self-selected samples. And here's some details. And what you see is that the gender gap in competitiveness, which is kind of the difference in the percentage of men minus the percent of women who choose to compete, is much larger when we have self-selected samples and non-self-selected samples. Now, it should be noted that while this would suggest that there could be selection bias, one cannot conclude this from the data. There's a major confound here. For example, non-self-selected samples in almost all cases tend to use like classroom experiments with non-student, like young individuals. So this is consistent with a selection bias, but it's not sufficient to conclude. So what we're doing is we're using a method which was similar to a paper I had with Blair Cleve and Bob Slonim in experimental economics, and it goes like this. At a certain point in time, we show up in a classroom, a large classroom, mandatory participation, and we measure the willingness to compete using a design similar, basically the same as Niederle and Westerlund. Then we follow what we consider to be standard process for recruiting people. Okay, so first we put them in a volunteer database, then we invite them to sign up in an experiment, then we see who signs up, who actually shows up in the lab. And this is how we identify lab volunteers. All right, we see who shows up in the lab. So then what we do is the following. So a little bit of notation. So delta P GT0 denotes the gender gap in competitiveness in the population at time t0. So at the time when self-selection is rolled out. And we have delta V, which is the gender gap in competitiveness among lab volunteers, which is also measured at time t0. Okay. So we say there's evidence of selection bias causing us to overestimate gender gap if the gender difference in the population is smaller than that amongst volunteers. Now, what's important here, people often confuse this, is that we do not use the measures of competitiveness inside the lab, because this would introduce learning confounds, time confounds, environmental confounds. Okay. So what we did is we went to this classroom, which is a course which is called Academic Skills at Erasmus, where Jan is, and we had a sample of 1,145 students over 96 tutorials. This is a compulsory tutorial for first-year students, and we did this in the first week, so there's no kind of contamination perhaps from what these kids are being taught. And we did this online, we programmed online, which lasted 15 minutes. And basically what we find, I'm skipping through this quickly, is that only 90 of them actually turn to be lab volunteers. So that's less than 8% of the entire sample. So there is a serious problem with attrition. The question is whether it introduces selection bias. So I'm just going to give you a quick snapshot of 3 findings. The first one is that we find clear evidence of selection bias in our estimates of gender difference in competitiveness. So what you have here is the fraction that chooses to compete. You see amongst lab volunteers, almost half of the population of men volunteers, or half of the volunteers, men compete, as opposed to 18% of women. So here we find the usual gender gap. If we look at that in the population, we again see a gender gap, but it is much smaller. So this is 15 percentage points compared to 31 percentage points. Once we control for differences in performance and other factors, that gap becomes actually, the selection bias inflates our estimates by 300%. Now, another result we find, a well-known result, is that men tend to compete too much. So what we do is we partition people into high and low performers. High performers are those with a score that gives them more than 25% chance of winning the tournament. 25% is, basically the point you would have the same expected value from taking part in the tournament or a piece rate. And I took for granted that you all know the Niederle and Westerlund design, by the way, so I completely skipped that over. Low performers is everyone else. So people whose performance would suggest that they should probably stick with the piece rate, if they're risk neutral at least. So what you see here amongst low performers, you see that men tend to overcompete. These people should not be competing. They should be at 0. Instead, 42% they compete. Amongst women, they're pretty rational here. In the population, you see actually, however, that the gap is much smaller. So actually here we find that here's where men tend to compete too much, and we have selection bias. If we look amongst high performers, and importantly to emphasize here we have the fraction that chooses not to compete. We see that in line with the literature, we find that high-performing women are more likely not to compete, all right, and men less likely not to compete. So men compete more. But what's important here is that we basically see the same gap in the population and in the lab. So this part of the result is not, we don't have evidence that is affected by selection bias. Here we do find evidence of selection bias. And if you notice here, it appears that men tend to select on competition. This is, I mean, here you don't see the sample size, it's less obvious for women. So the last thing I want to show you is evidence that men and women select differently into the lab. And this is quite important because if what we're trying to measure in the lab also predicts or correlates with selection into the lab, then we're going to have serious issues. And what we find, so here, the dependent variable is whether someone shows up for a lab experiment, and we control for their choice in the experiment. That's task 3 in Universal. The risk tolerance, then we have controls for their income, the leisure time they have available as they reported, self-reported, and some other things, including whether they were paid for the experiment. We only paid, like, I remember, I think 10% of the 1,145 subjects. So what you see here, the most important thing is, given the limited time, that the stars are in different places for men and women. So what you see, first of all, is that both the willingness to compete and risk tolerance seem to affect selection. And this is important because these are things we do measure in the lab. So, or I said affect selection, maybe I should say, they're correlated with selection into the lab. All right? These are things we are measuring in the lab. Most important, even more importantly, perhaps, is that for men and women, different things seem to matter. So men who are more willing to compete seem to be more likely to show up in the lab. For women, we see that the less risk tolerant they are, the more likely they are to go to the lab. I don't have time to show this here to you, but in the paper, we also show that we find evidence that selection bias causes us to overestimate risk, gender differences in risk attitudes. Okay, so I'm going to wrap up. Hannes, how am I doing? Is that a message for me? Fantastic. So I'm going to even give some time to listen for questions. Now, this is not a critique of lab experiments. Okay, lab experiments have advantages for studying gender differences. So we know that we can control for differences in ability that in a way that we cannot do in any other way. At the same time, there is a little bit of a paradox. If men and women differ in their willingness to select into competition or non-promotable tasks, it seems obvious that we should worry that selection bias could also affect the estimated differences too, right? So what we do in this paper is we provide evidence suggesting that self-selection could cause us to overestimate gender differences in competitiveness. We believe that, well, we also show that men and women appear to select differently into the lab, which can have broad implications for studying gender differences in general. We believe that we need to study gender differences in self-selection in greater breadth and depth. So breadth, I mean, we need to study it in other samples, other contexts, and depth, we need to go deeper. We need to understand why these differences may be there. Like I like to say, ours is but one data point. So maybe other labs, they don't have this problem. At the same time, it is one data point like any other empirical study. So the Nederland Westerlund, until it was replicated, it was just but one data point in Pittsburgh. So these are my co-authors, Aurélie, and Jan is here in the audience. So thank you very much.
Thank you, Nikos. Again, you saved a minute, so we're very well in time now. We have Lise Westerlund with her comment up next, and then some time for additional discussion. Sorry, you'll need to unmute, Lise. We can't hear you.
All right, and I'm also struggling to get my stupid slides to go to full screen mode. So, sorry about that. Okay, I can't get it to do what I want it to do. So good thing you saved them.
If you press F5 on your keyboard, that should do it.
I did that and it didn't do anything, but it helped when you said I should do it. So, okay, we're good. So thank you very much for inviting me to discuss the paper. Obviously, selection bias into the laboratory is something that we should be concerned about. And it's sort of, I'm gonna try to do this quickly since we have little time. But it's obviously one of the reasons why we should be, have been concerned about external validity more generally. We all know the debate. We've been concerned about participants being different in the lab, the environment being different in the lab, the incentives being different in the lab. And of course, selection into the lab is another reason why we should be concerned about being in the lab. And I think before I sort of go into commenting directly on the paper, I just want to remind us what it is that we're trying to do in the lab. We're not, at least any of the studies that I do not aim to estimate a quantitative difference that we think is going to be externally valid. What we're trying to look at is identify comparative statics. And we're assuming that those comparative statics are going to have external validity. And while there's been a lot of discussion on sort of the extent to which our laboratories have quantitative external validity, we have to remember that what we're doing as experimental economists, by and large, is to look at comparative statics because we've stripped so many other things away. So while it is concerning to see that there's selection bias into a laboratory, I just want to summarize the fact that both in the laboratory and in the full population, they find the effect that women are competing less than men conditional on performance. So when we start talking about external validity of the laboratory, let's just keep in mind that it's the qualitative differences that we are concerned about, not the quantitative. Nonetheless, it is concerning that there is so much selection in this particular study. And one of the concerns I have a little bit with this study is at least the recruiting procedures into the experiment is quite different from the way that we recruit at the University of Pittsburgh. The way we recruit at the University of Pittsburgh is that we send out flyers, we email anybody who moves, and we ask them to participate in the laboratory. Now, using this Cleve et al. Procedure, what they do instead is that they go into a classroom and they make people participate in an experiment. And the experiment they're participating in is the competition experiment. And of course, you would imagine that people who enjoy competing might be more inclined to then participate in future studies. So you do the competition experiment, and then you're invited to participate in other experiments. And part of the reason why I think there might be concern in the way that there are obvious advantages to doing this procedure because you manage to get the entire sample and their attitudes towards competition, and you can see who select into the competition. But it is unfortunate if the experience of having been in a competition is what causes certain people to enter the lab more than what we normally would. So I would certainly, and part of the reason why I'm concerned about this is that we sort of have the very competitive, high-performing types all going in at similar rates. But we know that one of the large differences that we see is that we see these overconfident, low-performing men generally competing far too much. And they are also the ones who are going into the laboratory at much too high a rate. So this could be a general phenomenon. I wish that there were, if we could, do a similar exercise with the people, randomize whether or not you get to opt into the lab or not, and look at the differences in that population and sort of ignore the within subject comparison. So I'm concerned about the experiment itself driving some of this selection bias. Certainly the effects are very large, and we should explore whether or not this is a general phenomenon. Also a little bit concerned about how small the sample is in terms of the people who are going into the laboratory. So the initial population is almost 1,200 people. The actual volunteers who show up in the lab, we're just looking at 90 people. And this is sort of going into the initial study. So they find selection not just in competition, but also on risk attitudes. Indeed, what they find is that the women who go into the laboratory appear to be more risk averse. And the concern in the sample is in part that this is the opposite result of what the initial Cleve et al. Study found, where they found that the more risk-seeking women are the ones who entered the lab more, whereas the risk-averse men seem to be the one who are more likely to enter the lab. So it is just to say selection certainly seems to play a large role here. It would be nice to do a larger study so we get robust findings on this, so that, if it is the case that more competitive men systematically enter the lab and more risk-averse women systematically enter the lab, then that is concerning. It would just be nice to have a larger sample to look at that in. And I must say, in light of the number of studies, including those that Nikos himself has run, characterizing the initial needle Vestlund as being one study. It was indeed one study, but this is a result that we've found, I would say, quite robustly in the profession. So I don't think it's fair to say that we have one study against another study. We have a very large set of studies across a large set of different domains that fairly systematically, I would say, more systematically than many of our other findings, find that conditional on performance, women are more reluctant to go into competitions. And just as a final note, in comparing sort of, unfortunately, we've gone to a point in the profession where we keep talking about the gender gap in competition. The gender gap in competition is only informative if we control for performance. And obviously this is the reason why we need to do this study, because, if I pull a whole bunch of studies from grade schools and I find that they don't compete as much as a bunch of kids who are going to college, there's so many factors that go into this. Do they believe that they're good? Or are we looking at a task where there should be a difference? I wouldn't expect the gender gap in competition to be independent of the task that we're looking at. We know that it shouldn't be. So it is certainly concerning that there's such a large difference in the lab and the population here. And I think it warrants more examination. I'm really glad that you're looking at this, but I do think that there is grounds to look at a larger sample and potentially see if there are ways to rule out the possibility that there is selection based on the initial experiment that they're in.
Thank you,
Thank
Lisa.
you, Lisa.
Can I give a couple of quick responses here?
Yes, sure. You have.
So all excellent comments about the order reversal that we could do, but perhaps doing the experiment first affects selection. That's certainly a possibility. In my previous study, where we did similar things, we didn't find that doing a risk experiment or a trust experiment affected selection. So that would suggest that maybe that's not the case. We also are collecting data of the reverse, what you're suggesting. Now we have not finished the measurement of the individual preferences. So we first invite them, we'll see who's a lab participant, and then we'll collect data in the population. But the aggregate data suggests that we get exactly the same levels of selection. So again, that suggests that doing the measurement with your task upfront doesn't affect selection. About the qualitative versus quantitative. I'm not sure here because in the sense that, if there is a big selection bias, theoretically speaking, then, we may observe a small effect in a study that if you went back to the population level, it would be zero. Finally, that's the last thing I want to say about the one study versus one study. Of course, it's not one study you have right now. I think what in my survey papers, like 27 or more that use exactly your design. What I meant to say is that we got rejected, and the critique was, oh, yours is one data point. This is actually something we wrote in the conclusion to the paper. And that is unfair because what I was saying, back in time, yours was one data point. What we're saying is, look, here's a big effect. Let's look more into it. And, to be asked to replicate this ourselves around the world before, it seems a little bit eccentric for an editor to ask. I'm not going to name this forum. But thank you very much. Please send me the slides.
I think it really points to selection, and we should be studying it. And the effects are much larger than what I would have expected. It would be really nice to understand better what it is that drives that selection.
I agree. Please send us the slides, would be great.
All right, thank you very much, Lisa. Thank you very much, Nikos. Thank you very much, everyone, for being part of this session. We managed not to be cut off in the end, right? So we do even have a couple of minutes left. So if there are questions, from the discussants or from the audience, then just raise your hand, or if you're a discussant or presenter, just unmute. John, hi.
Hannes, how you doing? So, happy New Year, everyone. So I'm gonna be a little bit selfish here and address Matthias his comment about our work. So the way that I think about the file drawer problem is if I hearken back to when I got involved with Claude Steele. So Claude Steele is a sociologist who's done really interesting work on stereotype threat. And I read his work with Aronson and I thought, wow, that's an amazing result. What I want to do is I want to try to find a demand curve for a stereotype threat and see how incentives change the nature and location of that demand curve. So I tried to replicate their results. Nothing. Tried to replicate them again. Nothing. At that point, I started calling a bunch of people in the literature. And what they told me was, oh, everyone knows that result on stereotype threat is so hard to get. We're not surprised that you didn't get it. And I said, well, where is that written? I don't know, we just don't write it up. So that's a point where if people would have registered that work, found no result, and then just buried it. So forget about contacting anyone, forget about their data. I could have gone to that registry and saw Claude had one, another person had one that was published, but then there were 22 others who did that same kind of experiment, and it never saw the light of day. I would have then said at that point, wait a minute here. I don't want to spend all kinds of time, which a lot of other people waste resources too. So for me, it's not, and then there was the first article is the same thing where they have the numerator. They could have had a lower bound on the denominator had they had some registry to rely on. So I don't think you need pristine information and all of the data to advance science and help to overcome the file drawer problem. I just need some semblance of what does N look like. And then I can call around and I would have saved all kinds of money and time. And that's the key that we're talking about here, the file drawer problem. Some people say, well, just replicate and that will take care of the issue. by the time that comes up, it's years and years and years. It's a lot of money. Our most precious asset is time. Some people publish papers that say the average hour is worth $19.75. We know that going down the wrong rabbit hole is really costly to society and to science more generally. And I think in that spirit is the way I view the file drawer problem being let's say, attenuated through registries. I'll stop there. That's what I was going to mention when I turned my camera on. Matthias, go ahead. I'd love to hear your response.
Thank you, John. Before Matthias responds, I have to warn you that we're going to be shut off in like a minute. If you want to continue the conversation, I posted a Zoom link in the chat to everyone. So if you want to continue the conversation, just switch over to the other chat, and there's no time limit there. For now, I would say thanks again. Thanks to the Economic Science Association for making this possible. And then I'll just have you keep on talking until we're shut down, right?
Thank you for setting this up.
Thanks for being here.
Thanks for sharing it, Hannes. Short reply, what are the incentives to post your results in the registry?
You don't have to post your
results. I agree with your main point. Yeah.
You don't have to post your results. You get all the benefits just by letting people know that it happened. That's my point. You don't need results.